Hey everybody, welcome to Systems Expert. Let's dive into the question.
So today, Clement, for this interview, I would like you to design a stockbroker. Stockbroker is a platform that acts as the intermediary or middleman between end customers and some central stock exchange.
Okay, a stockbroker. Is this a platform similar to the Robinhood phone application or the E-Trade website?
Precisely, yeah.
Okay. And what is this platform supposed to support exactly? I'm assuming that we're going to be supporting buying and selling stocks, but are we supporting trading other securities like options and futures? Are we supporting special types of orders like limit orders or stop losses? What exactly are we supporting here?
Right, so we're going to keep it a little bit more simple than that. I want you to support only market orders on stocks in this design. And a
Okay.
market order means that given a placed order with our brokerage platform, we should try to execute it with the exchange as soon as possible, regardless of the stock price.
Okay.
We're also not designing any margin system, so the available balance is the source of truth for that customer for what can be bought.
I see. So let me write that down. We are designing a system that supports market orders only for market orders for stocks. That's the main gist of it, I think.
Yep.
And are we designing any sort of auxiliary services that some of these platforms support, like depositing funds or withdrawing funds, downloading tax documents, that kind of stuff?
No, we're just designing the core trading aspect of the platform.
Okay. So just market orders for stocks, the core trading
Yep.
aspect of the platform. Are we are we supporting other types of operations that might be related to orders like, getting the status of orders or, listing all orders?
So no, not in this particular question. We could do that if we can do that if we have extra time. But I just want you to design a system around a place trade API call from the user, and I would like you to define that API call. So what kind of inputs it has and what kind of responses we can expect from it.
Okay, so I'll actually specify this then. We are working with a place trade API call, you said.
Yep.
Place trade API call. So this is going to be the primary API call that we're going to be making. But if we're not supporting functionality like withdrawing funds or depositing funds, like how are we getting a customer's money to actually execute orders? Will we have to interact with a bank directly?
No. So that's another part of it. You won't be interacting directly with the bank. You can assume that the customers already deposited funds into your platform. And you can assume that there's a SQL table, specifically SQL table, with the balance for each customer who wants to make a trade.
Okay, so I'll actually write this down as well. We have a SQL table for customer balances then, is that fair to say?
Yep.
Okay. So we have a SQL table for customer balances. Am I going to be writing down the SQL table? Like, am I going to be coming up with, its schema?
Yes, I'd like you to come up with a reasonable kind of schema for that table.
Okay. So SQL table for customer balances. And how many customers are we building this for? And also I suppose like, is this a global audience?
So I want this to be able to scale to millions of customers and millions of trades a day. We can assume that our customers are only located in a single region, let's say the US.
Okay. So we said millions of customers. So I'll put, millions of customers. You said millions of trades per day?
Yeah.
Millions of customers, millions of trades per day. So this is going to be a very, very heavy system. And you said only in one region, like the US?
Yeah. Let's just make it available only for a single region.
Okay, so I'll put US only. I suppose this design would probably be the same if it were for another region in the world, but the point is we're only catering to one region. And what kind of availability are we looking for this system?
We do want high availability with this kind of service because since it's dealing with money and stocks, people can lose a lot of money really quickly, even if it's down for a few minutes. So yeah.
Okay. Okay, so I'll write this down. High availability. This is probably something that I'm going to want to optimize on or, keep in mind. So high availability, needed. And I guess, let me see if there are any other things I'm thinking about here. Since we're going to be designing this place trade API call most likely. Do we also have to design a UI for this platform, or what type of clients are we expecting to be interacting with this API?
You don't have to design the UI, but you should design what kind of API call it will be making to the backend that you're designing. And for the clients, you want to think of them as either a mobile app or a web app.
Okay, I see. So we're really concerned with the API, not with designing the UI, but we do assume that we'll have some sort of UI like a mobile application consuming our API. That's what you're saying.
Yeah.
Okay. And then I guess my final question has to do with, at the very beginning, you mentioned that this platform is an intermediary between end users and some central exchange. So my guess is that this API here that we're designing, this Place Trade API, is actually going to be interacting with some other API that the exchange provides. Is this correct? And also, if that is correct, what does this exchange API look like? Do we have any guarantees from it?
Yeah, so you're right. Your platform's API, your platform's backend, specifically the Place Trade call, will eventually have to interact with the exchange's API. And as far as that is concerned, you can assume that the call to the exchange to make the trade will take in a callback in addition to the information about the trade that you're asking it to execute. And that callback will get executed when that trade completes at the exchange level, meaning either when the trade gets filled or rejected. You can also assume that the exchange has a highly available API and highly available system so that your callback will always get executed at least once.
Okay, I see. So you're saying that we will definitely be interacting with the exchange's API, and you said that we're going to have a callback that we can pass to it that is guaranteed to be executed when the exchange completes a trade. Is that correct?
Yes. So you can think about it as you will be notified by the exchange when the status of a trade that you have made changes.
Gotcha. Okay, so I'll write this in yellow again since it has to do with the API. We will have, a callback that we can pass to the exchange, a callback that we can pass, I'll put this as an arrow, to the exchange's API. And this will be kind of an on-complete callback. I'll write this on complete. So I'm assuming that we're going to want to have some pretty important logic in this callback that we might want to execute basically after we have that notification from the exchange that we completed a trade. But I guess this might become a bit more clear as we continue on with the design of the system. So I think that I have most of what I need here. I'll just reiterate the system that we're designing just to really make sure that I'm not missing anything. We want to design a stockbroker. So this is going to be a platform that sits in between end users and an exchange. The idea is the end users are interacting with it just like they would interact with a website or a phone application, and they're going to be placing trades. These trades are going to be done through this single API call called Place Trade. They're going to be market orders, meaning that you said that market orders means that we execute them regardless of price, like at the current price, right?
Yep, exactly.
Okay, let me just add this current price. That's what a market order is, just to confirm. And then we said that we have a SQL table for customer balances, and we're serving millions of customers. They're all located in the US or in a single region. Millions of trades per day. That's a lot of trades. We want a highly available system. And we have this exchange that's highly available itself that gives us this callback that's guaranteed to call when a trade completes. Okay. So the way that I'm thinking of approaching this design, or kind of like splitting it out, so to speak, is in 3 or 4 steps or categories. I guess the first one would be to really figure out or to hash out this place trade API, like, see what it looks like. And you said you wanted me to define it, right? With parameters, response type, and all that.
Yep. I want you to define the signature of the inputs and outputs of that call.
Okay. Okay, so that's going to be the first thing that I think I'm going to go ahead and do. The second thing would be to design, from a high level at least, just what our main backend servers are going to look like, meaning the servers that are going to be handling all of the place trade API calls. And then finally, I think that we can jump into the design for the actual, the part of the system that actually handles trades and executes trades, and this will likely be related to the exchange. This will likely be the part of the system that communicates with the exchange. Does that make sense from a very high level?
Yeah, I think that's great.
Okay. Okay, so I will give myself a bit of space here, and I guess I'll just write it at the top here very quickly. So first, we're going to do the API call. Then the second is going to be our API servers. So API servers. And then we are going to do our actual, let's say, trade execution system. Trade execution system. So for the API call, we're just designing this place trade API. I think that if this is, like, let's assume what happens when a customer goes on the app or on the website and buys a stock, for instance. They have to pick the actual stock. So this API call is likely going to take, the name of the stock, maybe the stock ticker. They have to define whether or not they want to buy or sell the stock, because they could sell the stock. So maybe we'll have like a type of the order, of the trade order. There's likely going to be a quantity, right? Because people can buy and sell multiple stocks. Is that correct?
Yeah. Yep.
Okay.
That's great.
And then, so I guess the API call, the way I see it, maybe I'll write it in red, is going to be something like, place trade, and it'll take in, before it takes in all of these parameters that I just mentioned, the stock ticker, the type of the order, the quantity of stock, I think it'll also have to take a customer ID, right? Because you are making a trade on behalf of a customer.
Yeah.
So I'll write that here. Customer ID. Then I think this will be stock ticker. Stock ticker. Then it'll be the type, and the type, like I just said, this is going to be like buy or sell, and then there's going to be quantity. And by the way, here I know that we're not designing limit orders or other types of orders, but I suppose we could have, if we were, we probably would have another parameter here that would define the type of the order, and depending on that, maybe have even more parameters. But for now, I guess we won't do that. Also, to clarify, the customer ID, this is really something that'll be generated kind of automatically, by the client based on authentication tokens or something like that. So this will be really, done securely. Do you want me to go more into detail about that, or?
No, I think this is fine. It's pretty standard.
Okay, cool.
Yeah.
So then the response for this is, because you want me to define the response of this place trade API call, right?
Yeah. I think we need. There's a few fields that aren't in the request that we'd want in the response.
Okay, yeah. So the response will probably even though we're not going to be designing, getting trade statuses or order statuses or a list of statuses, I'm assuming that we would still want some kind of identification for the order. So I think this will respond with an order ID. So I'll write this down here. It'll be kind of like an order ID. This will be generated by the backend in some way. And then I think it would just respond with probably the same parameters here. It would reconfirm basically the stock ticker, the type, the quantity. So I'll write this down: stock ticker, type, quantity. Just write quant for this. And then I think since we're dealing with a response, right, you always want a few more things. You probably want the status of the order, because maybe the order got rejected immediately, or maybe the order... Although I feel like since we are going to be dealing with the exchange, we're probably... The exchange, we said we have to issue an API call to this exchange to actually execute a trade, right? And it's only when we get the callback... It's only when the callback that we pass to the exchange, when that callback gets executed, only then do we know that our trade kind of like either succeeded or failed, right?
Yeah.
Okay, so then I think we still probably would want a status here. So I'll write a status, but I think that this status, I think this will always be just like placed. I'll use placed as the word for, you have put an order that has been successfully captured, but it hasn't necessarily been executed or filled, or it hasn't necessarily been rejected either. It's just been placed.
Okay.
So I think this will be the de facto response, but maybe you'll have other stuff. Maybe you'll have other potential statuses later on. And then finally, we also need like the time that this was created at. So I'll add this with a created at, and this is going to be, I guess, a timestamp for when this field, or when this order rather, this trade was created. Does this look good for our API call?
Yeah, I think this is great. Can you talk to me a little bit about the actual servers that will be handling this API call?
Yeah. Okay. So this brings us to number 2 now.
Mm-hmm.
So let's see. We are going to have a lot of servers, or rather we are going to have servers that are going to be handling a lot of these place trade API calls. That's the thing that we know for sure. And we know that at least some of these, actually all of these place trade API calls are going to also affect a customer's balance, right? Because if you buy a stock, you have to, deduct funds from your customer's balance. And if you sell a stock, you have to increase the funds. And you specifically told us that we have an SQL table for our customer balances, right? So
yeah,
we're going to definitely be editing this SQL table when, at some point, in the whole flow, probably after the callback gets executed on complete. So maybe not immediately, but we will eventually be dealing with this. This kind of tells me that we probably want to also store all of our trades or all of our orders in a SQL table, especially since, I know, once again, we're designing this very simply with just the place trade API, but it does feel like this platform would eventually want to support, listing trades, listing orders. So I think that having all of our trades or all of our orders stored in their own SQL table would make sense. Does that make sense to you, or?
Yeah, let's do that. Can you tell me a bit more as to how these tables look like?
Yes. Okay, so let me draw them out. Let's see. So I'll draw out both the SQL table for the trades and the SQL table for the balances. Okay, so the SQL table for the trades, let's see. I'll draw a bunch of columns for now, and maybe I'll eliminate some in a second. Let's assume that it's going to be a large table or a wide table. This will certainly be a very large table as far as the number of rows goes, because we're going to be storing all of the trades from all of the customers in this table.
Yeah.
So I'll write this here, trades. We're going to want every trade to have an ID. And I suppose this would be the trade ID or the order ID that we would return here in this API call. So I'll write this down here. This would be automatically generated. And this would probably be, an integer or a randomly generated string. Then we're going to want to store the customer ID because we need to know who issued or who initiated this trade. So I'll put C ID here. Then we are going to want to store the stock ticker. We're going to want to store the type. So I think we're going to want to store like all of these parameters that we passed here. So I'll put ST for stock ticker. I'll put type for buy sell. I'll put quantity, quant for quantity. We're also going to store, I suppose, the status. We're going to store the created at. Basically all of these things. So I'll put status. And status, by the way, I only mentioned placed earlier, but I think status will be placed. It'll be rejected if the order has been rejected for whatever reason. It'll be filled if the order got filled. And there might be, I guess, like an in progress while we wait for the exchange, like in between the time that we've issued a call to the exchange and in between the time that we are waiting for the callback to get executed. Does that make sense?
Yeah, sure. Let's have that.
Okay. And I just said, when I said rejected here, I said if it's rejected for any reason. This makes me think that we might actually have multiple reasons for rejections, right? You could imagine that you might get an order that gets rejected because you didn't have enough funds. You might get an order that gets rejected because you're outside market hours or something weird like that. So I'm thinking that we may want also another column for like reason, like a human readable message that explains why a trade got rejected or got filled. For filled, probably that wouldn't be relevant, but for rejection, it seems relevant. Do you think that makes sense?
Yeah. If you could add reason and also maybe, I guess you would add it to the response in the API. You don't need to add that, but just in between us. Yeah.
Yeah, it would be added probably as a final parameter in the response. Okay, but so this is the trades table. I guess we should also draw the balances table. So the balances table will probably look relatively similar. And I guess, by the way, we will likely want to index this table on one or more of these columns. Right now I'm thinking it'll likely be, like maybe it'll be the type of order or something like the customer ID, because you'll probably want to get all the customers' trades at one point. But I'll table that for now, and we'll see a little bit later.
Okay.
But so for the balances, let's see. Yes, the balances, it'll be also ID and customer ID. I think we might not need that many columns, but we'll definitely need ID. We'll definitely need customer ID. I'm assuming we'll need I guess I forgot in the trades here. I forgot to put the created at. Yeah, this parameter we'll definitely need in our columns here. So let me re-add that created at, and this is just a SQL timestamp. Does that make sense?
Yeah. Cool.
Okay. But so then here, customer ID for the balance, there isn't that much, right? There's an amount. So the amount is, if we're dealing only with the US, this is, floating point numbers that represent US dollars. And then is there anything else? I guess we can have maybe like a last modified field. So I'll put like last M, which would be like a timestamp for when we last modified the balance. But beyond that, I don't see anything that would be super relevant to us right now.
Yeah, we could add a currency column if we wanted to, or but for this particular purpose, we're only serving the US and we can just assume everything's in dollars. So that's fine.
Okay, cool. So now we're at this point where we have these tables rather with all the columns. I'm happy with what they look like, but I'm trying to figure out like how exactly this is going to get us to actually executing a trade. I guess the idea is, we were talking about the servers, right? We were talking about our API servers that handle millions of place trade API calls a day. So, if our API servers are here, for instance, um, let's write them here. These are our API servers. We're probably going to have a lot of them. They are getting calls from our clients. So I'll draw two clients that are making these calls. I guess we would have some kind of load balancer in between. So let me actually erase this. We would definitely want a load balancer to distribute, or a cluster of load balancers to distribute our API calls. And these red arrows here represent the place trade API call.
Okay.
So we would want this load balancer to distribute the load across our servers, our main API servers. Now, the main question that I'm wondering is, do we want any type of like super special server selection strategy at our load balancer level? Let's see, we're just placing trades. This is it's a very taxing operation in the sense that there are a lot of them, but itself, it's not super taxing, and we don't really need like any type of caching for this. So I don't think we need any type of like server stickiness here. So I don't think we don't need to optimize the server selection strategy for the load balancing to make sure that a certain client's calls gets forwarded to a specific server. So I think we can just do like round robin here, round robin load balancing. Does that seem okay?
Yeah, logic makes sense.
Okay, so I'll just put a few arrows like this to show that we're doing round robin load balancing. And then, so we have our API servers. We have also these two SQL tables. But what do we do with them? So we want to store our trades in the trades table. This seems kind of obvious. So, we would have our servers make writes to this trades table. But then we want to actually, send these orders to the exchange. Now, the problem is, if we are dealing with, let's say, buy orders, it's actually very important the order in which we execute the trades. And it's very important that we not get below, like that our customer has enough money, right? And we can only know if the customer has enough money from the exchange, because a market order, you said, gets executed at the current price regardless of the price, right?
Yeah.
Okay, so basically what I'm getting at is we cannot eagerly respond to the client, and we cannot eagerly update the balances table or like mark the trade as filled or something before we have talked to the exchange. And it's very important that we talk to the exchange in the order that trades come in, meaning the earliest trade, the first trade that came in, that hit our servers, right? Or the oldest trade rather, is the one from a specific customer, is the first one that should be executed. Now, I'm a little bit wary of having all of our servers, and I guess these servers aren't going to be the ones. These servers wouldn't be the ones who would be talking to the exchange. Like, if we had our exchange here, I'll write it in blue. This is the exchange. We probably wouldn't want these servers to be directly interacting with this exchange. Like, they're already handling a bunch of load here. So I'm thinking that we would want like another set of servers, like maybe workers, what I call workers here, that would be handling, all of the trades, maybe grabbing them from the SQL table and themselves going to the exchange and waiting for responses, and then maybe updating the SQL table. But I'm a little bit wary of this design, because I feel like things are gonna go very out of hand if we have like a ton of SQL queries happening in this table at once, whether they're coming from workers here or from these servers, if they're all trying to update like the same customer, especially since we went with a round robin load balancing approach. So you could have like two different servers with trades from the same customer trying to make an update to this table or something. So what What I'm trying to think of here is if we might not be better off using like a messaging system, like a publish subscribe messaging system, where we would basically route customers or customer trades, the trades pertaining to a specific customer, we were to route them to a messaging service, like a special topic or a special channel for that customer or for a set of customers, but with the same customer would always be routed to that topic. And we would have then our other set of servers, our workers, subscribing to those topics, subscribing to those channels, watching for new trades or notifications or messages coming in, grabbing them off of these kind of message queues, and then talking to the exchange. That way, I feel like it would be easier to reason about. It would be a bit cleaner than trying to have like servers all issuing queries to this database all at once for whatever customer. And I think we might be able to handle this system a little bit more properly. Does this make sense? I know I'm kind of speaking all over the place here, but
Yeah.
my like
So you're trying to use that messaging system to ensure that for a single customer, only one machine will be executing or trying to place trades with the exchange at any point in time, right?
Yes, yes. So basically, here we have our workers, and the idea would be, let's say we have a cluster of workers. And by the way, the reason we might have a cluster rather than only a single one would be if we want to really optimize for that high availability. And I'll get into what I have in mind in a second. But we would have like a cluster of workers that would only be handling trades, or not necessarily. They would be handling trades for multiple customers, but a single customer would only get its trades handled by a specific cluster of workers. So the flow from start to finish would be this. You have our clients here. This is an end user. Like, this might be me. I make an API call, the place trade API call, which would be because I want to buy a stock. It goes to the load balancer or the set of load balancers. It gets rerouted to one of our API servers, round robin. Here, we don't really care about server stickiness. This server makes a write to the trades database and stores the trade in here. But on top of that, so I'll write this down, I guess. So it stores it in this database. But on top of that, it creates a notification or a message, a PubSub message. And by the way, here we could use, Kafka or Cloud PubSub, Google Cloud PubSub. And we would have these topics here these PubSub topics that would have clusters of workers subscribing to them. So maybe I'll write them in blue here. We would have, topic number 1, topic number 2, topic number 3. And here I'll write another cluster of workers. So here, these are separated, right? These are different clusters. These would be subscribing to this. So they would be kind of, waiting here. These would be waiting for this, and these would be waiting for this, right? This would create a notification or a message that says, hey, I've got a trade from this customer. Let's call this customer C1. Okay, so this is C1 or client C1. I've got a trade from this client. I'm going to hash the client's username, for instance, and based on that, I'll route this trade, this message for that trade to one of these topics. So here we would care about the stickiness of the topic, so to speak. This is why we would we would hash this. And so let's say C1 would go here. We would have like a message here pertaining to C1. I guess I'll just write C1 here. We would have C1 that this server pushed, right? This server would basically push C1 to this topic. And then here, this would get, sent or streamed kind of, to the subscribers, to the consumers of this topic. And all trades from C1 would go here. All trades from, let's say, C2 would go to one of these topics. They would always go to the same one. We would also be guaranteed at least once delivery through these messaging systems. So we would know that we would never lose a specific trade, if that makes sense. And then the workers from here, they would see a notification and they would contact the exchange, right? And then we can get into the logic about how they, like, what happens when they contact the exchange. I think this is where the callback would come into play, but these workers would contact the exchange. Does this make sense sort of from a high level?
Yes. Can you go into how the workers within a group, within a cluster, kind of coordinate to figure out who does what?
Yeah, so here, this is where I'm thinking that this is where our system might start to fall apart. Like, we definitely don't want these workers to fail here because this is highly available.
Yeah.
We get some guarantees with PubSub, and by the way, I'll write PubSub here. PubSub. But we definitely, and here, if one of our server dies, our load balancer knows to reroute to another server. Our SQL database is safe, but this is what we really care about. So here, I think we could use leader election in between, or rather within server clusters or worker clusters, to have a single worker at any given point in time be the leader. So like maybe this one here would be the leader. Maybe here we would have this one be the leader. Here we would have this one be the leader. The leader is the one that takes care of messages coming in the topic, and that takes care of the logic of contacting the exchange. Does that make sense?
Yeah. Perfect. Cool.
And here within a cluster, I think 3 workers to start, maybe 5 workers would make sense, and we would have to monitor our system to see if this is appropriate.
Yeah.
Okay, so I think this sort of makes sense. We definitely need to look at what happens like with the exchange here in a second.
Can you tell me more about maybe how many different partitions or topics you would have? How many different clusters of machines to handle the load that we mentioned earlier?
Yeah. So like how many of these clusters or how many of these topics we would have?
Yeah.
Yeah. So I guess, first of all, the topics probably mirror the number of clusters because I think each cluster subscribes to one topic.
Okay.
But as far as how many of these, well, let's see. What was our load? We said that we are going to be expecting millions of customers, but I guess the number of customers doesn't matter really. It's more the number of trades per day. So, well, I guess the customers does matter because we're routing specific customers to a specific topic, but trades is really the important part. And if we have millions of trades per day, how many seconds in a day? There are 3,600 seconds in a day. Let's round this up to 4,000. So 4,000 multiplied by 24, that's roughly times 25, let's say 100,000 seconds in a day. So 100,000 seconds, and if we have a million trades per day, a million divided by 100,000, that is roughly 10. So 10 trades per second. So let me write that down. We are expecting roughly 10 trades per second. Although this is a stockbroker, right? My experience with stockbrokers is that like if you're in the US, you can only trade during trading hours. Is that correct?
Yeah. Or let's just assume that for the sake of this example.
Like the point is this is not a 24/7 system. So actually our trading load happens is like bunched up during a part of the day. Let's say that it's bunched up during a third of the day. We just multiply this by 3. So we're 30 trades per second. If we don't have a 24/7 system, it's more like 8 hours a day system. I don't know exactly how much it would be, but this would be more like 30 trades per second.
Right.
So the idea would be probably, 30 topics, or 30 clusters. Maybe you go a little bit above that so that the clusters are handling, less than 1 trade a second. So maybe you go with like 3 times this amount. So like 100 clusters and 100 topics. Does that seem reasonable?
Yeah, sure. Let's go with that. I just wanted to get an order of magnitude.
Yeah.
That's great. Cool.
So I'll write this here. I'll just put PubSub and I'll put 100 topics. And again, the number of clusters is equal to the number of topics. Okay, and here, by the way, just to make sure that we're on the same page, this is horizontally scalable, and also the workers are vertically scalable. Although here, I guess this doesn't really matter. This is more if we see that a lot of our workers are dying, because we will have only one leader at once taking care of the load. So, but I guess still we can have more than 3 or 30 clusters, more than 30 topics. And then at the end of the day, we are dependent on the exchange and how fast it can respond.
Right.
But cool. Okay. So the next thing now that we have to talk about, I guess, is what the actual logic at the exchange level, or rather at this level, like what is happening here that allows everything else to work. So
Okay.
at this point, when we are here, right, we have stored a trade in our table, and we have put its status as what? We have put its status as placed, right? So here we have put its status as placed. This is what we said earlier. At this point, the order is placed. We've created a pub/sub message here that got routed to a topic.
Okay.
Our workers here, or the leader of our workers, what it's going to do is it's going to say, given the next message in my topic, what am I going to do? Let's see. So the message would have a customer. Would the message have a trade ID? I don't actually think that the message needs a trade ID. I think the message can only be a customer. And what happens is the worker, or the leader here, gets basically the least recent trade from this particular customer by querying the database. And because we know that no other cluster is handling this customer, this is kind of a safe query to make in our database at this point in time. And we get the least recent trade from this customer. And depending on the status of that trade, we go to the exchange or we do nothing. In other words, if the trade is placed, then we go to the exchange. If the least recent trade is, not, and I guess here, no, we would be looking specifically for least recent trades that are not filled or rejected, right? We would be looking for trades that are either placed or, I suppose, even in progress. Like trades that are waiting for a response from the exchange. And based on those, we would then, go to the exchange to see what happened to them. If they're in progress, we're just waiting to see if the exchange has a response from them. And if they're placed, we actually execute them to the exchange. Does that make sense?
Yeah. Can you go into more details as to what this SQL query would look like? The one where you try to get the next kind of trade that you're going to be trying to check?
Yes. So basically, to clarify, so here we are subscribed to this topic. We get customer 1. We know that we need to do something pertaining to customer 1. Basically, this tells the workers, hey, customer 1 needs attention. So now the worker is going to go up here to the SQL database. And let me actually give myself some space. So I'll just write a smaller arrow like this. And here, this is the SQL query that we do. We basically do select all, so star, from trades. We are selecting all of the trades from a specific customer from C1. So where CID is equal to C1. And this is where, remember at the beginning I said that we might want to index on customer ID. I think this makes sense here. We would want to index on customer ID, so I'll put an asterisk up here. This means that we would want to index on customer ID. And so where CID equals C1, and we want, what do we want? We want only trades that are either placed or in progress. So, and status, so this is a combination of two things. Status equals placed, and here, by the way, I'm writing pseudo SQL, so to speak. Or
okay,
status equals in progress. So in progress is going to be what we set when the exchange, when we've like submitted an order to the exchange. And then since we are getting the latest one, we would order by and limit. So we would order by, what is it? Created at, right? This thing that we had here. So created at. And we would limit or order by ascending. And we would lim 1 to get the latest one.
Yeah.
Yep. Or limit, sorry. Limit 1. And so this would be our query. If there's nothing here, then really there's nothing to do, and this notification may have been kind of like at the end of everything that got handled for a specific customer. But if there is something, if we do have an order or a trade, let's go with an order or trade that's been placed, then we would issue a request to the exchange. Well, first of all, I guess we would mark this as in progress. Like if we receive a trade that is placed, we want to now make it in progress because we're about to talk to the exchange. So if it's placed, we would mark it as in progress. So I guess like this would now become, in progress. I'm overlapping here because I don't really have that much space, but in progress. And I'll talk in a second about what would happen if there's an issue here with our network, because you could imagine that we might set a trade as in progress, but then fail our network request to the exchange, which would be really bad. Like we never want a trade to hang, right? Like for this type of system.
Right.
Okay. So I'll talk about that. I think we'll have to have some kind of auxiliary service that handles that. But for now, let's just assume that we can make the network call to the exchange.
Okay.
So now we're going to make a call to the exchange. And here we're going to pass a callback to the exchange that is going to handle the logic of updating the balances table, updating the trades table, to marking this as failed or as rejected, as filled, etc. That'll be in the callback, which is guaranteed to be called by the exchange. And I think that's done. And then at that point, we mark this message as done, right? So that it can be kind of out of the messaging topic.
Okay.
So I guess we need to get into now what this callback looks like. Because by the way, for the in progress here, if we deal with something that's in progress, trying to think, I think right now my gut feeling is that we're just going to contact the exchange to see if there's been anything, like maybe to see if we've actually executed this trade to make sure that this wasn't some kind of error. And if we know that this trade is indeed in progress from the exchange, then we just wait. And I think that the callback is eventually going to come in and mark this as no longer in progress, right?
Yeah, the logic is roughly the same. If you get a trade that's placed and then you mark it as placed, whatever you do next will be the same as if you had just gotten the order as already in progress.
Yes, exactly. Okay, cool. But so then I guess now for the callback, the idea for the callback would be like the exchange will execute the callback when the trade completes. And so the trade will complete only if it's filled or if it's rejected, presumably, because we had that guarantee from the exchange. So let's go with the example where it's filled. I have a feeling that when it's rejected, it'll be very similar minus the update to the balance. But if the trade is filled, the callback that the exchange would have to do, or rather the exchange would probably issue a request to either one of our workers or probably like some separate server. I think it would be some separate server that does some transaction in the database. So I'll actually write this down up here. Like I think we would have a separate service that the exchange goes to when it's issuing the callback. Like the callback goes to here, and this server does queries or writes to the database or to the multiple databases in the case of a filled order. And these writes would look like this. I guess I'll skip writing, begin transaction. We would start the transaction. We would select the trade. So the exchange would have given our auxiliary server here the ID of the trade or the order that we're dealing with. So we would select all from trades where the ID is equal to that ID to grab the current ID that we're dealing with. Does that make sense? Or the current trade that we're dealing with. Okay. And so let's see. First of all, any logic that comes after, like now we're going to be like updating to trade to filled because this is a filled trade. We're going to be updating the user's balance. We might be updating other stuff about the trade, like the reason that it was filled or that kind of stuff. All this stuff we only want to do once. So if by any chance the trade at this point in time is not in progress, like let's assume the trade is already filled, we don't want to execute this logic. So we're going to have some kind of, if statement where, hey, if we're dealing with a trade that's already been completed, just roll back this transaction. Does that make sense?
Yeah, that's great. Yep.
And here, like the main thing that I'm worried about is when we're going to be updating the customer's balance. Updating the customer's balance is by nature not idempotent. So we have to be careful with that. That's why we have to make sure, just for safety, that the trade is still in progress and has not been filled or rejected. But assuming that it is in progress, then we can do an update to the balance for the customer, and we can set the amount to have, let's say we're dealing with a buy order, to be equal to negative, or to deduct the trade amount. Then we can update the trades, the status of that trade to filled, and then we can update the reason for which it was filled, which would probably be the same reason when we're talking about filled orders. It would be in rejection that the reason would be different. But so I guess I'll just write pseudo SQL here, okay? The idea would be you update balance, right?
Okay.
And you have like a trade amount, and again here I'm writing pseudo code rather than SQL just for simplicity. But you would have update balance, You would have update trade status to filled.
Okay.
Right, with the trade ID. And I guess here you would also need the customer ID for the balance. And then finally, you would have update trade reason. And I suppose we might also want in the database, something like executed at, or something like that, which would be, the time at which the trade was filled or the time at which it was rejected.
Okay.
And this would be given by the exchange. But so this is like the main logic in the transaction when you've filled an order.
Okay.
After this, you would commit the transaction. If you were dealing with a rejected order, you would just not have this update balance, but I think you would still update the trade status to rejected. You would still update the trade reason to whatever the reason it was rejected is. And after the transaction, after you've committed the transaction, so like this here is transaction, SQL transaction. After you've done this transaction, you would not only want to answer the exchange and give it a 200 to let it know that the callback's done, right? So like this would be 200, like I just finished calling your callback. But you would also want to notify the pub subtopic that this came from, right? Because like imagine that you had multiple trades from the same customer coming in like one by one.
Yeah.
This first trade would get taken by a worker. It would be a placed trade. So you would mark it as in progress and you would go to the exchange. But then you would go to the second trade, or you would go to the second message from the same customer. You would re-get all of the trades. You would see that the oldest trade is still in progress, right? Like basically, whatever trade we sent to the exchange would be in progress. And so you would skip. Right. Here we said like, oh, if we're dealing with a trade that's in progress, we skip, right? And so
right.
You would need another message here. Like once a trade has completed, you would need this server to say, hey, wait a second, go back to this customer. Like we just finished a trade for this customer. So workers, you need to go back to this customer because they might have something that still needs attention. And basically, so here, I'll mark it here, like after the commit, right? After the commit, notify PubSub. Notify PubSub that this customer might still need attention. And I'll put like an exclamation point because this is actually important, right? It basically means like, this is how this entire system functions, like this part. It's basically how like you're sure that a cluster of workers will never miss a trade from the table. Does that make sense?
Yeah. So essentially, you're making sure that as soon as a particular trade reaches a terminal state of either filled or rejected, the PubSub topic gets notified to make sure that the workers will pick up the next trade if there is a next trade that is in placed status.
Yes, exactly. And I think that like if we had a little bit more time, we could walk through an example where you've got, two back-to-back messages. I suppose I just did, right? And you would see how this works. So the first messages gets put as in progress. It goes to the exchange. The exchange takes a while to fill it. Then the worker grabs the second message, sees that, hey, the least recent trade is in progress. There are two trades, but the least recent one is already in progress, so I can't deal with the second trade. So I'm just going to skip for now. But you don't want to skip it forever. So once that first trade finishes or gets filled by the exchange and this auxiliary server marks it as filled, we need to notify the workers that, hey, go check if this customer still had other stuff, and then you would see that, oh, there's still one more trade that's placed and not in progress. So yes, this makes sense. There was one more thing that I wanted to say before. I think we are running out of time here, but I mentioned something about a network partition here, and I am scared that we might have cases where a trade has been placed but has never been sent to the exchange, or maybe for whatever reason it's in progress, but the callback from the exchange got lost. Like maybe this here, there was a network partition here or something. I'm not sure exactly what edge cases would cause this, but I'm scared that we might have some trades that do remain like placed or in progress but not handled, and that's really bad if we're dealing with a highly available system and if we're dealing with people's money. So I'm thinking that we might want to have another auxiliary service. So I'm thinking like, we'll write it here, like a Reaper service kind of, that would periodically, and I suppose it would have to happen pretty often, maybe every like 10 seconds or 5 seconds or something, periodically query all of the trades in the trades table that are placed or in progress and check if they're not being handled. Does that make sense? And if they're not being handled, it would have the job of going to the exchange and handling them or something like that.
Sure. Yeah, that makes sense.
This is why at the very beginning I had mentioned potentially indexing on customer ID, which we said would be useful because of this query. And so now I'm thinking that we also used the status here. So I think indexing on the status would also be useful here. So I'll add an index, and we could monitor our system to see if this is that useful.
Okay.
But so this is the overall design that I'm thinking of for the system. It's very complex, but I think that it accomplishes our goal of high availability, making sure that trades never get lost, that trades are executed sequentially, that we don't have like negative balances, all that stuff. What do you think?
Yeah, no, it definitely checks all of the invariants that we wanted to have for this system. So yeah, that's roughly what I was looking for. Thanks.
Okay, cool. With that, I hope that you found this video informative, and we'll see you in the next one.